So we ended the last video discussing, well, if you know that f prime is positive, then you know that f is increasing. If you know that f prime is negative, you know that f is decreasing. Well, what if you want to know when f prime is increasing? Well, if you want to know when f prime is increasing, like, you know what, you want to know when f prime has a max. Well, you want to know when f prime goes from increasing to decreasing. Well, anytime a function is increasing, its derivative is positive. And anytime any function is decreasing, its derivative is negative. We could keep going, like we did an example on the f triple prime. This could be the position, s of t. This could be the velocity, v of t. This could be the acceleration, a of t. In one of the quiz questions recently, we wanted to find the maximum value for the acceleration. Well, the maximum value for the acceleration is when the acceleration goes from increasing to decreasing. In other words, we have to take the derivative of the acceleration. Well, that's a prime of t. We don't really have, we haven't talked about what that actually means, but the derivative of the acceleration, if we want to maximize the acceleration, then we have to find when the derivative of the acceleration goes from positive to negative, and that's where we're going to have a maximum value. So no matter what, when you go one column over, that's always a derivative. And by the way, if by chance f, we didn't talk about this yet, but if f double prime is positive, and meaning that the derivative is increasing, that means that the function itself, so f then, would be concave up, and therefore if f double prime is negative, that means that f prime is decreasing, and that means that f is concave down. So you have to be very careful about and be very specific about what functions you're talking about. If you ever want to know when any function has a max, you have to take that function's derivative. Like I said, on the last quiz, you had to find the maximum value for the acceleration. So you had to find its derivative and find when its derivative changed from positive to negative. And that's just how it goes. No matter what the function is, if you want to know when it has a max, then you just have to figure out where it goes, where its derivative goes from positive to negative, and therefore where it goes from increasing to decreasing. The one thing we haven't talked about yet is inflection points. An inflection point on f would occur when f double prime changes sign. So when f double prime goes from positive to negative or negative to positive, that's where we have that math gang sign. That's where we have the inflection point. And to find where we have that, we have to set f double prime equal to 0. So just like a max or a min on f prime or on f, where f prime changes sign, and then we would have where f double prime changes sign, that's where we have the inflection points. So that's concept-wise for what you need to make sure you understand, and you can apply that to any situation in which you're trying to maximize or minimize something. You can apply that to the optimization problems, in which, hey, try to find a maximum value here. Well, how do we find a maximum value? Well, we have to set up a function, and then we test that function's derivative. Find where the critical points are. Goes back to this. If you want to know where you have an extreme value for any function, no matter what that function is, you test where that function's derivative is equal to 0, where the derivative doesn't exist, and the endpoints. So those are the only places where you can possibly have a max or a min, and that works that way with the optimization. The only difference with the optimization problems is that you have to create your own function. That's the only difference with the optimization problems from what we're doing right here. So that, just make sure you understand that, and I'm going to work through one example from start to finish so you can see it all in real time.